So question 6, consider f of x equal to x cubed minus 9 and g of x equal to the cube root of x plus 9. Find f of g of x, and then find g of f of x and determine whether the functions f and g are inverses of each other. As I said earlier, if these two composite functions are equal to each other, and basically they're equal to x, then the two functions are what we call inverses of each other. So again, inverse functions, remember, they basically undo what the original function has done. So again, if I look at f of x, notice how we have x cubed minus 9. So the first thing we're doing is we're cubing, and then you're subtracting 9. So if I reverse that process, what we should be picking up on is, if we go the other direction, the first thing I should be doing is adding 9. And then instead of cubing, we would be doing the cube root. So if we look up here, we are adding 9 first, and then we are taking the cube root second. So that looks like that's going to be the inverse. So I would say that these are both going to be equal to x, and we can move on. But if we want to go ahead and just verify this, so if I want to evaluate f of g of x, so we have f of, and then g of x is actually this cube root of x plus 9. So what happens is the cube root of x plus 9 is going to go into the f function 4x. So it's going to replace this x here. So what I should have now is this cube root of x plus 9 is going to go in place of x, and x is cubed. And then we're going to subtract 9. Well, one thing to pick up on is the cube root and cubing are inverse operations of each other. So they're actually going to end up being just canceling each other out. We have this x plus 9, and then we have subtraction of 9. And then 9 minus 9 does just give me x. That's what we were expecting. So again, if I do on a calculator the cube root of something, so if I put in parentheses the cube root math, we'll try it again. So parentheses math, cube root's number 4. If I've put, say, 7 in there, close that off. Oops. Come out, close off. And then if I raise that to the third power, notice that those two operations should cancel each other out, and I should just have the 7 again. So they basically just reverse each other. Also remember that cube root also represents an exponent. So this also kind of means x plus 9 to the 1/3 power raised to the third power. So remember, if you have a power to power, those exponents multiply together, and that's going to be x plus 9 to the power of 1, which is just x plus 9. So that kind of can be done that way too, by using what we call rational exponents. So if I want to verify g of f of x is equal to x, okay, I'm going to have this g function, but first I have to recognize what's the f of x function, and that's going to be the x cubed minus 9. So that's going to be what f of x is. And what happens is this x cubed minus 9 goes in place of x in the g function. So what this turns out to be then is, in the g function, we have the cube root, and then the x is going to get replaced by this x cubed minus 9. That's going to be my input, a whole function. And then we still got to add 9 to that. So if we do what's the side of the radical, notice that the negative 9 and the 9 will zero out. That's going to just give me the cube root of x cubed. And again, cube root and cubing are inverse operations, so this is going to give me x. So again, since g of x, f x, and f of g of x both equal x, we would say those two functions are inverse each other. So yes, f and g are inverses of each other.